By the end of this lesson, you will be able to use a map to work out how far apart two places are and decide whether your answer makes sense. Imagine planning a trip with a paper map spread across a table. The two places look only a few centimeters apart on the page, yet the real journey may take a long time. The map is giving us a clue, and we are going to learn how to read it. The routes on the map are much smaller than the matching routes on the ground, but their short to long pattern stays the same. Scale links map distance and ground distance through one fixed shrinking rule. Notice what the matching lengths reveal. Scale links map distance and ground distance. The same relationship is used across the whole map. A real area must be reduced to fit on paper, but the reduction has to stay the same for every route. This fixed proportion keeps the map dependable, so a longer ground route is still shown as longer than a shorter one. That gives the map a dependable pattern. Every real distance uses the same shrink rule. The fixed proportion keeps nearer and farther places in the correct relationship. Use the two distance layers to recall the connection. What does scale link on a map? The matched routes give us the answer. Scale links map distance to the corresponding ground distance. The upper and lower layers show the two distances connected by one rule. Next, let us learn how that relationship can be written as a scale statement. A scale statement tells what a measured length on the map represents on the ground. For example, 1 centimeter on a map may stand for 500 meters or 100 kilometers in the real place. Keep the two sides of the sentence together. A scale statement matches map and ground distance. Read the number and its unit exactly as they are printed. The equals sign links two matching distances for this particular map. It does not mean centimeters and kilometers are the same unit. Read both the number and unit on each side, because 500 meters and 500 kilometers are very different distances. The unit changes the meaning completely. Read every scale value with its unit. The number alone cannot tell the correct ground distance. Read the printed relationship carefully. On a map marked 1 cm on the map equals 500 m on the ground, what ground distance does 1 cm represent? The right side of the statement tells us. 1 centimeter on the map represents 500 meters on the ground. The value and unit after the equals sign give the real distance. Next, we will read the same distance relationship from a printed scale bar. A scale bar is a marked line that compares map length with equal ground distance segments. The route from A to B covers two sections of 1 kilometer each, so it represents 2 kilometers on the ground. The matching lengths do the reading for us. A scale bar converts length by comparison. The route is matched directly with marked ground distance segments. Use the scale bar like a reference ruler made for that map. Compare the route with its marked sections first, then read the ground value at the matching endpoint. Two equal 1 kilometer sections give 2 kilometers. Watch where the matched line ends. The scale bar endpoint gives the ground distance. Read the value only after the map route has been aligned with the bar. Use the two equal sections as your clue. If the route from A to B matches two 1 km segments on the scale bar, what is the ground distance? The alignment makes the result visible. The ground distance is 2 km. The route covers both 1 kilometer segments. Next, we will measure a route and complete the full conversion procedure. Measure the route first, round only when an estimate is needed, then multiply by the scale value. Here, 3 centimeters at 4 kilometers per centimeter gives a ground distance of 12 kilometers. Follow the order shown by the arrows. Measure, round, multiply, then state the unit. Each step prepares the value for the next one. The scale can be used only after finding the map distance. 3 centimeters means 3 groups of 4 kilometers, so multiply rather than guess, and include kilometers in the answer to show it describes the real ground distance. The units show what each number means. Map centimeters become ground kilometers through the scale. Keeping the units visible prevents centimeters on the page from being mistaken for kilometers on the ground. Work through the 4 steps in order. A route measures 3 cm on a map with a scale of 1 cm equals 4 km. What ground distance should be stated? Now compare your result with the scale. The ground distance is 12 km. 3 groups of 4 kilometers make 12 kilometers. Next, we will use the given relationship 2.5 centimeters equals 500 kilometers. If 2.5 centimeters represents 500 kilometers, divide both sides by 2.5 to find that 1 centimeter represents 200 kilometers. A 4 centimeter route then represents 800 kilometers. The 1 centimeter value unlocks the calculation. 2.5 cm equals 500 km gives 1 cm equals 200 km. Once that unit value is known, any measured map distance can be converted. Divide both parts of the scale statement so the map and ground values stay matched. Once 1 centimeter equals 200 kilometers, a 4 centimeter route contains 4 equal groups of 200 kilometers, giving 800 kilometers. Both sides must change together. Divide the linked values equally before multiplying. This keeps the scale relationship correct from the first step to the last. Use the 1 centimeter value shown in the middle. Using 1 cm 200 km, what ground distance does a 4 cm map distance represent? The repeated groups confirm the calculation. A 4 cm map distance represents 800 km on the ground. 4 groups of 200 kilometers make 800 kilometers. Next, let us compare how much detail maps show when they cover small and large areas. A large-scale map shows a small area, such as a neighborhood, with more detail. A small-scale map shows a much larger area with less detail, because many small features must be left out. Keep the shared frame size in mind. Large scale means small area, more detail. Small scale means large area, less detail. A page has limited space. Fitting a small area into it allows streets and buildings to be drawn clearly, while fitting a large area requires broader information and fewer details. Scale describes this relationship, not paper size. The page space stays limited. More area on the page means less local detail. Fitting a broad region into one frame requires simplification. Use the amount of detail as your clue. Which map usually shows more local detail? A large-scale neighborhood map or a small-scale country map? The neighborhood panel shows the pattern clearly. A large-scale neighborhood map usually shows more local detail. A small covered area leaves room for streets, blocks, and buildings. Next, we will bring the lesson together by checking units, calculations, and reasonableness. 6 centimeters on a map with a scale of 5 kilometers per centimeter represents 30 kilometers. A good scale answer uses multiplication, gives the ground unit, and makes sense for the situation. 3 checks make the answer dependable. Check the operation, value, and ground unit. All 3 parts must agree with the scale and the map situation. The word every means 6 equal groups of 5 kilometers, so multiply to get 30, not 11. The final unit must be kilometers because the result describes the ground distance, not the line length on the map. A correct number can still have a wrong unit. Reasonable answers match both calculation and meaning. The result must fit the scale relationship and describe ground distance. Bring together the scale, operation, and unit. A route measures 6 cm on a map with a scale of 1 cm equals 5 km. Which answer is reasonable? Now we can test the complete answer. The reasonable ground distance is 30 km. 6 groups of 5 give 30, and kilometers is the ground unit. You are ready to measure map distances, convert them, and check whether the results make sense.